From ContainerDays Hamburg, this video is proudly presented by Dux IT.
Hi everyone, thank you for coming. We are going to talk today about OCI hooks and basically what they are and how do they fit with that beast called Kubernetes runtime management. So yeah, as was previously said, my name is Igor. I'm working as principal software engineer in Red Hat and in the virtualization team, which is part of the OpenShift virtualization product. I'm also a core maintainer of the kubelet project, which is the open source alias for OpenShift virtualization, more or less. So yeah, today we are going to cover a few things. First of all, some background before we will dive into OCI hooks. Then basically the definition of them, use cases, what could be the alternatives, and wrap up with Q&A. So let me start from a brief history of the container technology. Well, this, we can talk about it like for the whole lecture. So I brought it here to emphasize a few steps in the evolution. Basically, before Docker, let's say it like that, it was not that easy and not portable to use containers. And then Docker came with the portable image and the image format thing, and also with the more or less easy tooling. So between the 2010 and 2020, there was that container explosion, and other actors want to play also in that role of Docker. So only we can say somewhere in between. So in 2020s, we have the real standardization of how to run containers and how to pack them. So why standardization matters in that scope? Well, imagine a scenario there was no standardization. So you probably had like 5 or 6 cloud providers and you have your application. So you had to create and pack your application in 5 different ways and to manage it, continuously deploy it. It was like a maintenance hell from my perspective. So between the 2010 and 2020, somewhere in, I think, 2015, the Open Container Initiative was created by the main big companies in the cloud sector. And this specification defines 2 ways, how to run the container and how to pack the container. It also helps create a modular approach for the container technology, and we will see it right now. So basically, we have the standardization, we have specification of OCI. We can think of a mental model of 3 layers. We have the container runtimes, engines, and orchestrators. So let's go briefly each one of them. Let's start talking about the container runtimes. So basically, what is a container runtime? It's a tool that helps you create the silo for your application and basically to prepare the required resources for your application. It could be the mounts and other devices on the operating system on the hardware. It can also create the security isolation if needed, and it needs to initiate or to fork the application to that silo. Well, can you use only container runtime to run the container? Yes, but it will make you, it's not that easy. So you have to prepare your application files, which is like the root file system. You will have to use the OCI runtime config to declare how you want to run your application, also to prepare the resources, and then to launch the application inside that silo that you have created. So what is this OCI runtime specification or config looks like? So in short, to simply speaking, it's like a declarative way of how you would like to run your application inside the container, inside the host. You can provide the executable, the environment variables your executable may need, the path to the root file system where your application and all the dependencies are residing. And also you can declaratively say which resources and restrictions you would to apply for your application. Here I brought you, like you see the Linux and namespaces, but pay attention that you see the Linux, it could be any other operating system. So basically the OCI runtime specification doesn't refer to a specific operating system. It can be used broadly with other operating systems that are running on the host. So if we are talking about only the container runtime, I brought you an example how a container can be run with only the runtime. So the runtime doesn't responsible for bringing the root file system for you. You have to use external tooling or whatever you need to bring the application files on the host. Then you need to create that spec that we previously saw. Now, you don't have to remember all the spec by yourself. The runtime tools can create you a template by running runc spec or crun spec or whatever. You can pipe it to a file. And then you can modify the parts that you need for the application to start running. In that example, I brought the hello world container. So I put the Podman hello world executable. And I also defined the rootfs. And this is basically how you run with only the container runtime tool, the container. So if that wasn't that easy, so how can we then integrate or how we can more easily use the container runtime? It's with the container engines. And simply speaking, a container engine just knows how to render that OCI spec file and how to bring the container for you. So most of you, I think, familiar with the container engines that were like in the 2010s and 20s. It's Podman and Docker. So you can, in the command line, you can specify what you need for your application and what's the name of your application, what's the name of the image. And obviously, with container engine, one-liner, and you run your application, comparing to the runtime, which we had to do a lot of things by ourselves. And now I bring you another example, and this is a container engine that was evolved for the cloud, for the Kubernetes world. So this is not a one-liner, obviously. And here you can see how to run the same hello world with CRI-O, which is one of the popular container engines for the Kubernetes, for the cloud world. Here you can see that once again you have to do these stages more or less manually to pull the image, to create the abstractions, and to start your application. So, okay, if that wasn't easy, then we have maybe another top-layer solution that can integrate with the engine. So this is the container orchestrators, and I think you are familiar with most of them. It's the famous Kubernetes and Docker Swarm, and there are others that are more like companies that runs like Red Hat, OpenShift, and OpenShift Virtualization. You have Rancher, if I'm not mistaken, and other flavors. Also for the edge world, you have K3S, K0. So basically what the container orchestrator is doing is to give you an API or to give you a declarative manner to focus on your application rather than focusing on operating system specifics. You can declare how much replicas you want for your application. You can be focused on the lifetime for your application. For example, in some circumstances, you need to terminate it because you see some scenario that your application will not function properly. So you have the liveness probes and health checks. So this is like few examples from the container orchestrator responsibilities. So how then the orchestrator communicates with the engines? So in Kubernetes, you have plugin systems. You have a few of them. You have for storage, for example, you have the container storage interfaces, container networking interfaces. We will talk about the container runtime interface. So container runtime interface is a communication standard between the orchestrator and the engine. So if you are an engine and you want to comply with the orchestrator, you can use the CRI API repository, and the opposite. If you are a container orchestrator and you want to use CRI-compatible engines, you can use the same CRI API. The CRI API repository defines basically the life cycle for the container that you need to comply. And in regards to Kubernetes, you have the kubelet, which is the Kubernetes agent that runs on the worker nodes. And what it does, it complies or it communicates with the CRI using the CRI API and also managing the pod lifecycle through the container engine. So this is an example, a flow from Kubernetes regarding the pod lifecycle. So if a user creates a pod or deployment, it's being admitted to the API server. The kube scheduler puts a node label on the deployment or on the pod spec. Then kubelet sees that it needs to create the pod. What it does, it communicates with the container engine using the CRI API. And you can see these 4 bullets: pull image, run pod, sandbox, create and start the container. It's the same way we saw previously how you run manually the container using CRI-O, right? So basically this is how it goes. And then you see that CRI communicates with the OCI runtime. It basically forks the runtime tooling with the rendered OCI spec. So if you remember what we said previously, the container engine renders the OCI spec based on the user needs. So you can even think of the bottom layer of container runtime as a square inside the container engine layer. Yeah, and now we come to OCI hooks. So OCI hooks are part of the OCI runtime spec. So this is basically the background we saw. The spec defines the OCI hooks as optional, which means that if you are a container runtime tool, you don't have to implement the hooks in order to comply with the upper container engines. But in practice, it's supported by runc and crun, but it was implemented in these tools. And as we previously saw, the container engine is responsible for rendering the hooks. So the container engine has to support them as well on his layer, as his level. Okay, then why should you use OCI hooks? So I took it from the OCI runtime specification, but simply speaking, it could be that you have a custom hardware resource. Your application needs it. I know that there are maybe device plugins, you have a DRA in Kubernetes, but sometimes it may not be enough, and you need to use the OCI hooks to set up the hardware, the devices, and pass them to the container, especially when the container is unprivileged, and you need to, let's say, fix the permissions or the ownership on the files. Another thing is when it's not about permissions, but about some custom cgroups that were created, but they're not covered by the OCI runtime spec yet. Or it was covered by the runtime spec, but the container engine doesn't support it and it doesn't expose it in the CRI API level yet. And maybe you want to play with it and test it for production, and you want to take time to introduce it to the upstream, but till then you want to still use it in your production or staging environment. Yeah, well, how can you use them? So even that the container runtime, it's like the bottom layer, it has like a small life cycle of the container. So you have like 5 stages when you can put the hook. And the third stage is a different one because in that hook you are operating inside the container namespace, while in other hooks you are running in the host view and you are privileged. That means that you can create that point when you need to do something privileged inside the container before the container proceeds to the next stage in its life cycle. So in the lifecycle also is pretty simple. It's like you can opt in the start or opt in the end. Yeah, well, if you think that it fits your requirements, how can you use them? So you need the container engine to render them to the OCI hook, to the OCI runtime specification. Yeah, and it looks like this. You need to provide two things. You need to provide the configuration of the OCI hook, I mean, how to run it, and what to run, the executable itself. Because the runtime tool, in the end, it will parse, it will render the path, and it will fork it. Yeah, but the runtime spec is rendered by the engine. So the engine has to support it. And what if you don't want in your cluster for that hook to run for every container? So what you can do is to go like for the container engine implementation. And here I show you the implementation of CRI-O, how it treats hooks. The most important part is the when in the hook. In the hook struct, you can specify under which circumstances you want the engine to react and to inject the hook to the spec. These annotations, they come from the upper layers, from the CRI API and from kubelet. So these annotations can be injected by user, by maybe by the orchestrator. When I mean orchestrator, it could be mutating hooks, mutating webhooks. It could be injected by the container engine implementation itself. And they actually, sometimes they do that in order to fix permissions, but yeah, that's another story. And there are also other fields, like you saw previously, that comply to the spec, which command to run, and all other things, which are less important. So this is like how the configuration looks like. If you take a look on a particular worker node that uses CRI-O as an engine, you need to specify, you need to deploy basically two things: the configuration for the CRI-O, so it will know that it needs to render the OCI hook under which circumstances. For example, here you see on the right side, when the entry point command of the container has like enter or systemd, it will inject the hook configuration to the OCI specification, which will be treated later on by the container runtime. So where it comes handy in our project that we developed for the OpenShift virtualization, we needed to opt in for swap memory. Now, swap memory in Kubernetes, it was like, I don't know how many decades for it was in beta. They didn't take it to GA because they were afraid of swap causing I/O latency and harming the quality of service of the pods. But for our case, for OpenShift virtualization, when we do run virtual machines inside pods, we do have some degree of predictability when we need to use swap and when we don't. And in the legacy virtualization, swap was enabled, and virtual machine were using memory overhead, so obviously they had to do page in, page out, so it was taken into account. So we wanted to opt in for using swap in the pod that runs the virtual machine inside. Since swap memory on the, let's say from Linux OS perspective, you just have a single cgroup, which you need to set to specific value, and then the container will be eligible to use swap memory from the operating system perspective. So we created wasp-agent, which basically touched that cgroup file. And this is how it works. The wasp-agent daemon set is being installed on the worker node, so it's a privileged one. The deployment, it looks like two stages. It installs the OCI configuration, and then it installs the OCI hook executable on the node. And since it uses when always true, if you see that, so we previously said that, hey, I don't want OCI hook to run for every container, so why do I use here always true? This is because there is not enough information that is being passed to the engine and to the runtime. Sometimes I want to opt in for all the containers in their lifecycle, and I want to check from the hook itself whether I want to configure cgroup swap memory or not. So this is like one of the drawbacks that we will talk about later on. Yeah, so this is the lifetime. A new pod scheduled, kubelet initiates CRI-O and starts the life cycle. CRI-O renders the hook, and the hook gets into the spec, and runc or crun sees the config.json and the hooks and forks the hook basically. So, drawbacks of OCI hooks. So as I previously said, they are one-off stateless operation. It's like a callback. So when you run inside a callback, you have like a very, very strict sandbox, and you need to be synchronous, and it's very hard to debug it, for example. And if you need to communicate with other components, it will introduce latency for the container bring up lifecycle. So it's a little bit problematic. And also, as you previously see, I use the when always. That is because not enough information was passed to that layer. So alternative is NRI. NRI is basically same thing like OCI hook. It's a plugin system, and it is operating on the container engine level. And moreover, it's not only that it operates on the container engine level, it's a stateful one, and it's compatible with the CRI API. So what it basically means that I can register that plugin for every CRI request method I want. Create container, update resources. So if I register to these methods, so everything will be passed proxied to the plugin, and it will return it back to the container engine. And the container engine will proceed with the life cycle, which means that I can manage my custom logic in a stateful manner outside, and I will be consistent with the flow. Unlike the OCI hooks that we previously saw, that if you touch a cgroup, it can be then overridden by some update resource request, and then you will have a race condition, which is super hard to debug, especially on these lower levels. Yeah, so wrap up. What we saw is a very brief summary of container evolution and technology, standardization, which could lead to the separation of concerns, the runtimes, engines, and orchestrators. Then the practical implementation of the layers. We talked about OCI hooks, use cases and tips, what to use, what not to use, and how. Yeah, so thank you.
Thanks a lot for the great session.
Sure.
Let's see if we have questions. They're coming right in. Let's start with the first one. Are these hooks visible in Kubernetes anywhere, like audit logs or events?
So they not natively. It's more related to the container engine, and only if you have some operator or a logging system on the Kubernetes that can bring you that, some ELK or something that you can see, then, because it operates on the node level.
Thank you. The second question is around, are there advantages to OCI hooks compared to NRI?
Basically, it's OCI hooks, they were created before NRI, and OCI hooks are on the container, they are working on the container runtime level. So the only advantage is that if you don't have that layering on the top, and you need to you need to hook to the container lifecycle, and you don't have the ability to hook from the upper layers, this is the only way to do that.
Thanks a lot. Any more questions? Everyone typing? Perfect. Can you elaborate on the OCI definition for pod definition? For example, if Docker run seems to run just a container comparison to podman.
So the OCI, in the end, OCI definition is more low-level oriented for the, let's say, operating system world, while pod definition should not concentrate on the infra. It should give you should be infrastructure agnostic. Pod definition should be more application centric. If this is what this means.
Yeah, I think so. Hopefully it was answered. The next question would be, are there use cases for managed Kubernetes engines like AKS, ECS, etc.?
So I think that in managed Kubernetes engine, you don't have the ability to use OCI hooks. And moreover, I think this engine by themselves are using these hooks in order to log some host-oriented information in the pre-start or post-stop levels. I don't think you have this level of control on the managed Kubernetes in the cloud.
Thanks. And the last one would be, how do you set up your environment? Single node, OpenShift setup, custom build, or something else?
So what do you need to do? You do need to configure, to enable OCI hooks on the container engine configuration file. So for CRI-O, by default, when you install the nodes and you DNF install CRI-O, it's enabled by default. I don't know about ContainerDays and other engines. I know that it's enabled in CRI-O by default, and you can see the directories where you need to use a drop-in to put the configurations there.
Perfect. Thanks for answering. Thanks again for the great session. I wanted to clap now, but my hands are full. Please do it for me.
Thank you. Thank you.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.